Good morning, students. Today we are going to see coterminal angles. Angles have the same initial side and terminal side, but with different amount of rotations are called coterminal angles. Okay, they will have the same initial side and the same terminal side, but the amount of rotation is different, means those angles are called coterminal angles. Okay, so if alpha and beta are coterminal angles, means we can write beta is equal to alpha plus k into 360 degree. Some angle is added with the multiple of 360 degree. Here k is an integer, that means it takes negative values, positive values as well as 0. For example, k is equal to 1, 2, 3, etc. So k is equal to -1, -2, -3, like that we can write. Beta minus alpha can be written as k into 360 degree. So the difference of coterminal angles is a multiple of 360 degree. Okay, you take 45 degree and 405 degree first. So 45 degree, the initial side is OA and it rotates in the anti-clockwise direction and takes this much amount of rotation. You see that red color, I have marked the amount of rotation of 45 degree. So the terminal side is OB. Okay, 405 degree, it is greater than 360 degree. So in the anti-clockwise direction, it makes one complete rotation and plus 45 degree. So it will come in the same terminal side. So 45 degree and 405 degree have the same initial side and the same terminal side. See the amount of rotation, this much is for 45 degree. 405 degree after making one complete rotation and up to here. So therefore these two are coterminal angles. You consider the negative angle minus 315 degree. So angle is in negative, so it has to move in the clockwise direction. So for that, OA is the initial side. This ray rotated in the clockwise. You see that up to this it is 90 degree, 180 degree, 270 degree, then 45. So then only you will get minus 315 degree. So minus 315 degree also having the same initial side and the same terminal side. So these three angles are called coterminal angles. Come to the exercise 3.1, the problem number 2. For each given angle, find a coterminal angle with a measure of theta such that 0 degree less than or equal to theta less than 360 degree. Okay, the theta, the coterminal angle, what you are going to find, that should be 0 degree to 360 degree, but it should not take 360 degree also. Okay, because it is less than 360 degree only it is written. Okay, 395 degree, how it will be written? So 35 plus 360 degree. Okay, it is greater than 360 degree, so 335 degree plus 360 degree. So beta is equal to alpha plus 1 into 360 degree. 395 degree minus 35 degree, that is equal to 360 degree. So therefore the coterminal angle of 395 degree is 35 degree. You see the amount of rotation how I marked. You see now, so 35 degree, for 35 degree the initial side is OA and 35 degree lies in the first quadrant. So this much amount of rotation it takes, and this is the terminal side. OB is the terminal side. Now I am going to mark 395 degree. So 395 degree, for that also the initial side is OA. After making one complete rotation it comes to 35 degrees, so it has the same terminal side. So therefore they are called coterminal angles. Next one, 525 degree. So that can be written as 360 degree plus 165 degree. So beta is equal to alpha plus 1 into 360 degree. So the coterminal angle of 525 degree is 165 degree. Here you have to write the multiples of 360 degree. Okay, and you see that 165 degree the initial side is OA, and after crossing the first quadrant it comes to the second quadrant because it is greater than 90 degree. So first quadrant to second quadrant. So this is the terminal side of 165 degree, and 525 degree is greater than 360 degree. So after making one complete rotation in the anti-clockwise direction, it has to move to 165 degree. So the same terminal side it has. So therefore the coterminal angle of 525 degree is 165 degree. At the next one, third subdivision, 1150 degree, it is more than 360. So here I have written 1080 degree plus 70 degree. Why I have chosen? Here I have to write a multiple of 360 degree. So 1 into 360 degree is 360 degree. 2 into 360 degree is 720 degree. 3 into 360 degree is 1080 degree. So here I have written a multiples of 360 degree plus the remainder angle. So 1080 is 3 into 360 degree plus 70. So the remaining angle is nothing but the coterminal angle of the given angle. So see that 70 degree, it is less than 90 degree, so it lies in the first quadrant. For 70 degree, the initial side is OA, and this is the terminal side. For 1150 degree, how you have to mark? It has to complete the 3 complete rotations. So in the anti-clockwise direction, 1 complete rotation, and the second complete rotation, and the third complete rotation. After that, it has to come to 70 degree. So the same terminal side it has. Okay, so come to the fourth subdivision. What is it? Minus 270 degree. So it is a negative angle. So while you are writing negative angle, so be careful in writing it. So minus 360 degree plus 90 degree. Okay, see, minus 360 degree plus 90 degree. So when you go for this subtraction, you will get minus 270 degree. So minus 270 degree coterminal angle is 90 degree. You look at your minus 270 degree. How will you mark? It is a negative angle, so it has to move in the clockwise direction. So OA is the initial side. This initial rate takes rotation in the clockwise. So if it comes here, it is 90 is over, next 180, and then minus 270, and 90 degree, it is in the first quadrant. So this is your terminal side. The positive y-axis, the terminal side lies in the positive y-axis, that is OB. So both having the same initial side and the same terminal side. Okay, so see now next one, minus 450 degree. So it can be written as minus 720 degree plus 270 degree because it is greater than, what is it, 360 degree. So minus 720 degree plus 270 degree, and this can be 720 can be written as minus 2 into 360 degree plus 270 degree. So the coterminal angle of minus 450 degree is 270 degree. Okay, here you see that first diagram. So it is 270 degree. So this OA is the initial side. This ray takes rotation in the anti-clockwise direction. So 90 is over, 180 is over, then 270. The terminal side OB is here, and minus 450 can be written as minus 360 degree minus 90 degree. So both are in the what is it, clockwise direction. So 90, 180, 270, 360, one complete rotation is over in the clockwise, then it has to come minus 90 degree. So it has the same terminal side. Okay, so see now here I have written minus 720 degree plus 270 degree. Okay, here in this diagram I have marked it as minus 360 degree minus 90 degree. That also you can write, but in your question what that and the angle should be, where, how it should be, it is, see that question, the angle, the coterminal angle with the measure of theta such that 0 degree less than or equal to theta less than 360 degree. So what is it, 0 to 360 degree positive angle only it is asked. Okay, so if I write minus 440 degree as minus 360 degree minus 90 degree, your coterminal angle is in clockwise direction, that is minus 90 degree will come, negative angle will come. But you have to write the theta as a positive angle, 0 degree to 360 degree. Okay, so that's why here I have written minus 720 degree plus 270 degree. 270 degree is a positive angle. It lies less than 360 degree. It lies in the third quadrant. Okay, so next one, you see the third problem. If a cos theta minus b sin theta is equal to c, show that a sin theta plus b cos theta is equal to plus or minus square root of a squared plus b squared minus c squared. First take the given result and squaring on both the sides. So when you square, it is in the form of a minus b the whole squared. So it is a squared cos square theta plus b squared sin square theta minus 2ab cos theta sin theta, that is equal to c square. Bring the c squared to the left side as minus c squared and bring this term which is in the minus in the left side, take it to the right side and call this as 1. And what the result you have to prove, you take it a sin theta plus b cos theta and square it. It is in the form of a plus b the whole squared. Write a squared plus b squared plus 2ab. Okay, so from 1, in the place of 2ab cos theta has to be written as a squared cos square theta plus b squared sin square theta minus c squared. So you just group the terms a squared and cos sin square theta, a squared cos square theta. From that a squared is taken out, means it is sin square theta plus cos square theta. From these two terms b squared is taken out, means it is cos square theta plus sin square theta minus c squared. So you know that this identity is 1. So therefore a squared plus b squared minus c squared. This is the answer for a sin theta plus b cos theta the whole square. What is asked? A sin theta plus b cos theta. So that is equal to plus or minus square root of a square plus b square minus c square. Okay, and the fourth one, if sin theta is plus cos theta is equal to m, show that cos power 6 theta plus sin power 6 theta is equal to 4 minus 3 into m squared minus 1 the whole squared by 4, where m squared is less than or equal to 2. So m squared is greater than 2. Suppose here I am writing m squared is 3. What is 3 minus 1? 3 minus 1 is 2. 2 squared, it is 4. 3 4s are 12. So this angle, this term will not angle, this term is negative. So it should not be negative. So therefore they have written m squared is less than or equal to 2 there. So take the given result. What is the given result? Sin theta plus cos theta is equal to m. Squaring on both the sides. Sin theta plus cos theta the whole squared is equal to m squared. So it is in the form of a plus b the whole squared. So a squared plus b squared plus 2ab is equal to m squared. So what is sin square theta plus cos square theta? That is equal to 1. So 1 plus 2 sin theta cos theta is equal to m squared. 2 sin theta cos theta is equal to m squared minus 1. So call this as 1. And consider the result what you have to prove. Cos power 6 theta plus sin power 6 theta. This can be written as cos square theta the whole cube plus sin square theta the whole cube. It is in the form of a cube plus b cube. How it will be written? A cube plus b cube. A plus b the whole cube minus 3ab into a plus b. Again I am repeating, a cube plus b cube can be written as a plus b the whole cube minus 3ab into a plus b. What is your a? It is cos square theta. What is your b? Sin square theta. So it is a plus b the whole cube minus 3ab into a square plus b square. So this identity is 1. So it is 1 cube minus 3 into cos square theta sin square theta. This also 1. Okay, here it will be written as cos theta sin theta the whole squared. So from this result, what is sin theta cos theta? M squared minus 1 by 2. So when you substitute and if you square, what the answer you will get? So it is m squared minus 1 the whole square divided by 4. You look at the term. Okay. So see now here, when you square it, it is, if you take LCM, so the answer is 4 minus 3 into m squared minus 1 the whole square by 4. And come to the fifth problem. What is if cos power 4 alpha by cos squared beta plus sin power 4 alpha by sin squared beta is equal to 1. Prove that the two subdivision you have to prove. So in the first subdivision, your question is sin power 4 alpha plus sin power 4 beta is equal to 2 sin squared alpha sin squared beta. All the terms are in sin. So take the given result. From that, the cos has to be changed in terms of sin. For that, this cos power 4 alpha can be written as cos squared alpha the whole squared. Okay, see, you know the identity. Sin squared alpha plus cos squared alpha is equal to 1. So from that, your cos squared alpha is equal to 1 minus sin squared alpha. So in the place of cos squared alpha, it is written 1 minus sin squared alpha the whole squared. This cos squared beta has to be written as 1 minus sin squared beta. And what you have to do, it has to be expanded using the formula a minus b the whole squared. You look at this. What is it? A squared plus b squared, that is sin power 4 alpha, minus 2ab, that is 2 into 1 into sin squared alpha, that is 2 sin squared alpha. Here you have to take LCM. So what is the LCM? 1 minus sin squared beta into sin squared beta. So this has to be multiplied with this term. So that's why I have written into sin squared beta plus, next, what the previous step, you are having sin power 4 alpha into 1 minus sin squared beta has to be multiplied with that. So I have written here divided by 1 minus sin squared beta into sin squared beta, that is equal to 1. So if you expand, 1 into sin squared beta is sin squared beta plus sin power 4 alpha into sin squared beta minus 2 sin squared alpha into sin squared beta. When you expand this, 1 into sin power 4 alpha is sin power 4 alpha minus sin power 4 alpha into sin squared beta divided by the denominator sin squared beta minus when you multiply these two, it is sin power 4 beta, that is equal to 1. And from here you see the term sin power 4 alpha sin squared beta. Here also sin squared 4 alpha plus into sin squared beta. So it is in plus, it is in minus, both getting cancelled. So the remaining terms I have written, and the denominator when it is multiplied with 1, you will get this answer. You see the left side sin squared beta, and the right side also the same term is there. So both getting cancelled. So you will get this result. Bring the sin power 4 beta to the left side, so it will become positive, and the negative term of 2 sin squared alpha into sin squared beta, when you take it to the right side, it is positive. So we have proved the first subdivision. Come to the second subdivision. You see the question, the given result and the result has to be proved. Look at this. So what's the difference? Here you are having alpha, here you are having beta. In the place of beta you are having alpha. So same result we have to prove, but the angle is different. That makes a lot. Okay. So see now, the first subdivision, this is the result we have proved it. So take that result and arrange it. Sin power 4 alpha plus sin power 4 beta minus 2 sin squared alpha sin squared beta is equal to 0. It is in the form of a minus b the whole square. So what is a? It is sin squared alpha minus sin squared beta the whole square. It is equal to 0. Okay. So the square of the term is equal to 0 means sin squared alpha minus sin squared beta is equal to 0. So sin squared alpha is equal to sin squared beta, which implies sin alpha is equal to sin beta. You call that result as 1. Next, from that sin squared alpha, it can be written as, using the identity 1 minus cos squared alpha. The same way sin squared beta can be written as 1 minus cos squared beta. 1 getting cancelled. So the remaining is what? Minus cos squared alpha minus cos squared beta. From that minus getting cancelled. So cos squared alpha is equal to cos squared beta. You will get cos alpha is equal to cos beta. Now you consider the result, what you have to prove. So write it. See, from 1 and 2. So what is 1? Sin alpha is equal to sin beta. Second is what? Cos alpha is equal to cos beta. So here this term cos beta the whole power 4. So in the place of cos beta, you are going to substitute cos alpha because both are equal. So cos power 4 alpha. In the same way, in the place of sin beta, you can write sin alpha. So sin alpha to the power 4. So if it is getting cancelled, so the remaining is cos squared alpha plus sin squared alpha. It is well known identity, so that is equal to 1. So we have proved the result. And coming to the problem number 6, y is equal to 2 cos alpha divided by 1 plus cos alpha plus sin alpha. Then prove that 1 minus cos alpha plus sin alpha divided by 1 plus sin alpha is also y. You take the given result I have written. Here you have to multiply and divide by the conjugate. While you are taking conjugate, you just combine 1 plus sin alpha. So here it is given us in the denominator 1 plus cos alpha plus sin alpha. You just take first 1 plus sin alpha plus cos alpha and take the conjugate 1 plus sin alpha minus cos alpha into divided by 1 plus sin alpha into minus cos alpha, because in this result, what the result you have to prove, here you are having 1 minus cos alpha. So the conjugate is 1 plus sin alpha minus cos alpha. The numerator is multiplied. There is no change. And come to the denominator, it is in the form of a plus b into a minus b. So that is a squared. What is a? 1 plus sin alpha the whole squared minus cos squared alpha. Okay, come to the denominator. We have to arrange the denominator. Numerator has to be written as it is. So it is a plus b the whole squared. So a squared plus b squared plus 2ab minus cos squared alpha. In that, what is it? Just combine the first term and the last term, that is 1 minus cos squared alpha plus second term cos sin squared alpha plus the third term 2 sin alpha. What is 1 minus cos squared alpha? That is sin squared alpha. If you add these two, sin squared alpha plus sin squared alpha is 2 sin squared alpha plus 2 sin alpha. From these two terms, what is common? 2 sin alpha is common. If you take it out, what is remaining? You see that if you take it out, what is remaining? 2. From that, 2 sin alpha is taken out. It is sin alpha plus 1. So 2 sin alpha getting cancelled. You got the result. We have taken the first result as y. So we have changed the right hand side and we have proved like this. So this also y. So we have proved the result. Thank you, students.